So hello friends, in this tutorial number 7 we are going to learn about raster analysis. So before beginning, at first we have to know the difference between the vector and the raster. From our tutorial 1 to tutorial 6, that is georeferencing, digitization of map, geoprocessing, table operation and query, symbology and the map layout was all about the vector. And from this tutorial number 7, we are going to begin our raster type of analysis. So in this raster, we are going to learn about raster analysis and the spatial interpolation. The main difference between the vector type and the raster type is that the vector is in the line form, that it is in the coordinate form, but the raster is in an image form. For clipping in the vector data or vector type data, we can simply use the clip tool from the geoprocessing. But for clipping the raster data, we have to use the raster clip because it is in the image form, and the format of the file for the vector is .shp, and the format for the raster type file is .tif. So this is all about the difference between the vector and the raster. And for the vector type, just we have completed our all tutorial for the vector, that is from georeferencing to the map layout. And from this raster, from this tutorial 7, we are going to begin our raster type tutorial. And in this raster type tutorial, the raster analysis will be the first tutorial, and the last tutorial will be the spatial interpolation. So let's begin. So before beginning, at first you have to download this file from the description. Then you have to unzip this like this, and you have to keep this folder inside the GIS folder by creating the folder name Raster Analysis, and inside this Raster Analysis you have to extract the downloaded file into it. So after doing this, then you have to open the Arc GIS. Then after opening Arc GIS, at first you have to refresh the GIS folder by right clicking on this, then click on refresh. Then after refreshing, it will show the new folder, that is Raster Analysis. So at first we are going to create a file geodatabase for the raster analysis. For that, just click on this plus sign, then click here, right click here, go to new, and click on file geodatabase. Then write the name raster. Then enter. Then after doing this, at first we have to let me see. Yes. Then after creating a file geodatabase, we have to import all this file into the geodatabase. So at first we are going to import the raster type file, and the raster type file we can see the dm nepal.tif and the tnow dm.tif is the raster type data file, and the rest is vector type data file, because we can see from this format, that is .shp denotes the vector type and .tif denotes the raster type. So for importing this data into this file geodatabase, for that you have to right click here, and at the first we are going to import the raster type data. So for the raster type data importing, you have to right click on this raster geo database, then you have to go to import, and from import you have to click raster data set. Then after this we have to drag the raster data file into this, like dm Nepal, then now dem. Then doing this, after dragging this both file, you have to simply click on OK. Then it will take a little time for importing this data into this raster geo database. It may take 1 to 2 or 2 to 3 minutes depending upon your processor. So you have to be patient. Then the process for importing the raster data to the geo database is completed. Then you can see here by clicking on the plus sign, that is DM Nepal, and the now DM is imported to the raster geo database. Then after this we are going to import the vector type data to the raster geo database. For that you have to simply right click here on the raster geo database, and then go to import, then features class multiple, then you have to drag the simply vector type data to this one by one, this, then after this file, then the tower. Then after this you have to simply click on OK. Then it will import the vector type data to the this raster geo database. Then it will take a little time for importing. Then after importing, it will show this type of dialog box. Then you can see the, by clicking on this plus, you can see the all the data of the vector and the raster type data is imported in the raster geo database. Then after this, in this tutorial we are going to learn about a basic set of raster based analysis, including displaying digital elevation model DEM, raster clipping, slope aspect, uh, the hillside, and viewshade calculation, distance buffer analysis, reclassification, vector to raster conversion, raster to vector conversion, raster calculator, and the last weighted overlay. And for understanding this all, we are going to solve this number of exercises for understanding the basic of raster analysis. So let's begin. So at first we are going to display the DEM into the Arc GIS. Then after that we are going to see the layer properties. So for this, go to Arc GIS. Then you have to drag the TNAV-DM from this raster geo database into this workspace like this. Then you can see this TNAV-DM. DM is the simply digital elevation model. So in this first tutorial we are going to view the layer properties, and for viewing the layer properties of this, simply right click here and go to properties. And from these properties, at first we are going to click here on the source, and from this source we can see the cell size is 29 into 29. It means the pixel size is 29 by 29. It means the size of one pixel of this raster file is 29 by 29. Then after this, then after seeing the cell size, you have to simply click on OK. Then our first tutorial is completed, that is the layer properties for the DEM. Then in this B number, continuous symbolization, that is uh, this type, stretch type. For that, you have to go to the Arc GIS, right click here, properties, and from this properties you have to go to the symbology, and from this symbology, let me see, from this symbology you have to click here stretched, and click on labeling, or click on OK, then click on apply, then OK. Then it is for the continuous symbolization stretched. Now the B is completed, and for this C number, that is for the symbology of type classified for the discrete color, we are going to follow this procedure. Simply right click here, go to properties, then after this go to symbology and click on classified, and from this classified click on classify, and okay, and from this you have to choose the color ramp, choose the distinctive color ramp, or this color might be, let it be this, and the number of classes be 5. Then click on apply, then OK. Then our tutorial number C is completed, that is just we have classified for the discrete color. You can see from here, that is this blue color denotes the lowest elevation, and this red color denotes the most highest elevation. So in this way, our first number tutorial, that is displaying DEM, that is digital elevation model, is completed, that is layer properties, continuous symbolization, and the classified symbolization. So now in second number, we are going to find out we are going to calculate the slope of that TNAV DEM, and for this we have to go to the Arc toolbox, and from Arc toolbox we have to follow this syntax. So for that, simply go to Arc GIS and click here on the Arc toolbox, and then after clicking this type of dialog box will appear, and from this you have to go to the spatial analysis tools, and then simply you have to click on this plus. Then after this you have to click here on the surface on the plus sign. Then after this we have to click on this option, that is slope. Double click here. Then after this we have to drag the TNAV DEM into the input raster. Then after this, simply you have to click on, or after dragging this, write the name as TNAV slope, then click on OK. What is so at first we have to make this geodatabase default before beginning our exercise. So for making the default, we have to go to catalog and right click on the geodatabase and choose this option, make default geodatabase. Then after this you have to go to Arc toolbox, then from this go to surface, then double click on this on this slope. Then after this you have to drag this file dm, then write the name as slope. Then after writing the name you have to simply click on OK. Then it will convert, or it will display the slope of dm model dm. Then it will take a little time for processing. Then after processing we can see the slope, and from this we can see this type of green color will denote the 0 degree to 8 degree slope, and this red color will denote the 45 to 70 degree slope, and likewise others. So in this way we have calculated the slope of the dm. Then after doing this we are going to calculate the aspect, and for calculating the aspect from this surface we have to click on the aspect, double click here, then you have to, in this above you have to drag the dm. Then after dragging this data dm to this, we have to write the name aspect, then click on OK. Then it will take a little time for processing. Then it will display the aspect of dm dm. Then we can see the aspect, and from this figure, this red color denotes the north, this pink color denotes the northwest, and this is for the degree, that is 0 degree to 22.5 degree denotes the north, and 22.5 degree to 67.5 degree denotes the northwest. Likewise others denotes the southwest, south, southwest, west, northwest, north. So in this way we have calculated the aspect, that is 0 mean north and 180 degree mean south. So after completing this 3 number, we are going to solve, or we are going to calculate the hillshade, and for calculating the hillshade, at first we have to know the basic, that is the azimuth is the angular direction of the sun. It is measured from north in clockwise degree from 0 to 60 degree. 90 degree means the position of sun is in the east, that is the azimuth determines the position of sun. 0 degree to 360 degree. 90 degree means east, 180 degree means south, and 0 degree means north. So in the default, the data will be set in 350 degree, that is 315 degree is northwest. So and second variable is altitude. Altitude is the slope or angle of illumination source above the horizon. The units are in degree. 0 means on the horizon, 90 degrees mean the overhead, and this simply determines the position of sun on the horizon or above or overhead. So the default value will be 45 degree. So let's begin for calculating the hillshade. For that, go to Arc GIS. Simply double click here on the hillside. Then after double clicking on the uh, hillshade, at first you have to drag the TNAV DM into this data input raster. Then after that, we are going to write the name TNAV hillshade. Then after this, we can see the value for the azimuth is 350 degree and the value for the altitude is 45 degree. This means 350 degree means the northwest, the position of sun is the northwest, and the altitude of the sun is 45 degree, and by positioning the sun, we can see the we can see the for the hillside for this TNAV DM. Then after writing all this value, you have to simply click on OK. Then it will take a little time for processing. So the process is completed, and we can see the final drawing of the TNAV hillside. So this is all. So this is all about the calculating the hillside. So in this 5 number, we are going to calculate the viewshade, and for calculating the viewshade, at first we have to go to the Arc toolbox, then Spatial Analysis tool, then Surface, then Viewshade. So for the viewshade, we can see the definition from here. That is, a viewshade allows you to determine which area on a landscape can be seen from a feature like a point location. So in this tutorial, we are going to see from this tower data, that is from this tower point, the viewing area. So for that, at first uncheck this, then drag this data tower from the view database to the working space. Then after this go to Arc toolbox, then you have to click on the viewshade, double click here, then in the input raster you have to drag the TNAV DM, then insert or polyline feature input point, you have to drag the tower point into it. Then after doing this, you have to simply click on OK. Then it will calculate the viewshade, that is the viewing area from this tower point. So the process is completed, and you can see from this drawing, this green color denotes the visible part and this pink color denotes the not visible point. So from this combination of this tower, we can see this green color part only. From this tower we cannot see this pink area. So this is all about the view shade. So in the sixth number, we are going to clip the Nepal DM with the Tina water sheet. So this is all about the raster. So we are going to use the raster clipping. For that, go to Arc GIS, go to search and write raster clipping, raster clip. Then click on search. Then after this, at first we need the data of DM Nepal and the Tina water sheet. So for that, at first you have to drag the DM Nepal data and the Tina water sheet to this working space. So simply zoom to layer and uncheck this. So for clipping, uh, from this search box you have to write the raster clip, and from raster clip you have to choose this option, clip data management. Then after this, at first we have to import this DM Nepal into this input raster. Then in this second box of output extent, we have to drag this Tina water sheet. Then after dragging this, you have to simply check this and click on OK. Then it will clip this DM Nepal to the Tina water sheet file. It will take a little time for processing. After processing, it will show the result on this screen. So you have to simply wait. The speed depends upon the configuration of your PC. So I think the process is almost completed. Yeah, the process is completed, and you can see at first you have to uncheck this, check this, or even also uncheck this. Then this is the file created. Then simply right click here and zoom to layer. So in this way, just we have clipped the DM Nepal to this DM T now. So this is all about the raster clipping. So now in the seventh number, we are going to learn about distance and the buffer analysis. For that, at first we have to uncheck this and go to catalog. So at first we have to drag the TNAV stream file into this workspace. Then simply uncheck this at first. Then go to Arc toolbox, and from here you have to go to this spatial analyst tool, and from this tool you have to click on the distance, and from this distance you have to click on this Euclidean distance. So simply double click on this Euclidean distance, then it will show this type of dialog box. So in the input raster you have to drag the TNAV stream, because we are going to create a buffer zone for this TNAV stream. Then after doing this, you have to click on this environment, Then after clicking on the environment, you have to click on this processing extent, and we are going to show this buffer zone for the TNA water sheet. So from this extent we have to select this option, same as layer TNA water sheet. Then after doing this, you have to simply drop down, then then from this you have to click on this raster analysis, and from raster analysis, from this cell size we are going to select the same as layer as DM Nepal. Then after doing this, you have to simply click on OK, and then again click on OK. Then after clicking, it will take a little time for processing. Then after processing, it will show the final result. So in this tutorial 7, we are going to learn about the buffer analysis. So it is processing. So you can see this is the final drawing of the buffer zone for this TNAV stream. So simply right click here and zoom to layer. Then after this, you have to simply, you can click on TNAV stream and the TNAV water sheet, and you have to double click here or a single click on this, choose this option, the hollow, then OK. Then this is all about the distance and the buffer analysis. So in this we have learned about the how to buffer this streamline into this zone like this in a simple step. So after completing this, in this next number is reclassification. We are going to reclassify the elevation of water sheet into 3 classes. So for this we have to go to, for the reclassification we have to follow this syntax. Go to Arc toolbox, this Arc toolbox, space analyzed and reclass. From this reclass you have to click on this reclassify. Then after doing this, at first you have to uncheck this all, then you have to drag this TNAV DM to this, then you have to click on this classify. Then you have to choose the number of classes, the number of classes as 3. Then after selecting the number of classes 3, go to this method, and from this choose the manual. Then after clicking on this manual, you have to click here and write 500, then enter 1500, enter, then 1901, then click on OK. Then it will classify the elevation into the 3 classes, that is 133 to 500, 500 to 1500, and 1500 to 1901, and write the name as TNAV class. Write the name as classified elevation. Then click on OK. Then it will classify the elevation into the 3 classes. Then after classifying this, we can also classify for the slope into the 3 classes. So let it be completed, then we can start for the slope classification. So in this way, just we have classified So just we have classified the elevation into the three classes, that is in the this sky blue color, this pink color, and this brown color. And now after classifying the elevation, we are going to classify the slope. And for classifying the slope, you have to simply click on this reclassify. Then you have to drag the TNAV slope to this input raster. Then click on classify. Then click on number of classes to 3. Then after this, click on manual and write the slope value to 25. Then enter 40. Enter. Then 70. Let it be. Then OK. And write the name classified slope. Then OK. Then after doing this, it will classify the slope into the three classes. It will take a little time for processing. After processing, it will show the final result for the reclassification of slope. Then after reclassification, we can see the classified slope, and from this slope we can see this green color, blue color, and the red color denotes the classified slope. So after doing this, we are going to the ninth number of exercise, that is raster calculator. And for the raster calculator, we are going to solve the four number of exercises. So at first we are going to find the area whose elevation are above 1000 and below 1500. So for that, the syntax is, or the process to go to the raster calculator is Arc toolbox, Space Analysis tool, Map Algebra, and the Raster Calculator. So for that, go to Arc GIS. Then after going to the Arc GIS, we have to go to the Map Algebra, and this is the Map Algebra. Arc toolbox. Then you have to go to Spatial Analysis tools. From this, you have to go to Map Algebra. Then you can see the Raster Calculator. So simply double click here on the raster calculator. So in the first exercise, we are going to find the area whose elevation are above 1000 and below 1500. And for that, the syntax is this: dm greater than 1000 and less than 1500. Here the mistake is 500, but the actual value will be 1000 here, and here 1500 is alright. So for this, go to ArcGIS, and after clicking on this raster calculator, you have to choose the dm from here. So at first, before clicking, you have to give the you have to click here on the bracket, then dm, then greater than 1000, and then bracket close, then and then again in this bracket dm less than 1500, then bracket close. Then you have to click here at the outside box and write the name dm1. Then click on this. It will show the area for the elevation above 1000 and below 1500. So it is processing. So after processing, it will show the final figure here. So it is completed. At first you have to uncheck the classified slope, and from this we can see the this final drawing, and this 0 denotes the unsatisfied criteria, and this 1 denotes the satisfied criteria. Satisfied criteria means the elevation above 1000 and below 1500. So this green color denotes the elevation for above 1000 and below 1500. Then after performing this, we are going to perform the number 2 exercise for the raster calculator. That is, we are going to change the dm elevation into the feet. At first it is given in the meter, where so from meter we are going to change into the feet, and the syntax is dm multiplied by 3.2. If you multiply the meter into 3.2, then it will change into the feet. So for that, go to Arc GIS, then raster calculator. From this raster calculator, you have to click on this dm, then multiply, then 3.2, then click here, then write dm2, then okay, then it will then it will change the dm elevation from meter to feet. So it will take a little time. It is now processing. After processing, it will change the meter into feet of dm elevation. Then you can see the meter is converted into the feet. That is 6083.2 feet and 425.6 into the feet. So after doing this, we can move to this exercise number 3. So in this exercise, we are going to provide the actual above of the elevation above 1000, not 0 or 1 value. Just we are going to show the actual dem of the elevation above 1000, and for that the syntax is this conditional, then dm greater than 1000, then dm. For this, go to ArcGIS, then go to Raster Calculator, and from here, at first you have to click here on the conditional, then dm greater than 1000, then click here, or bring this cursor after comma, then again click on this dm, then again cross this. Syntax is right, so click outside and write the name dm3. So after this, click on OK. It will take a little time for processing. After processing, simply uncheck below, uncheck also this, then you can see the final result is like this. It will only show the elevation above 1000 only, and the elevation below 1000 it will not show in this drawing, because we are going to only because in this syntax we have just written the we have We have written this syntax for showing the elevation above 1000 meter only. So it will show the drawing for the elevation above 1000 meter only. So after doing this, we are going to move to the this exercise. That is, at first we are going to create the hillshade 0, then hillshade 90. Then after this we are going to add this both hillshade 0, hillshade 90. And for that, go to Arc GIS, drag this, and from this surface click on this hillshade. And from this, at first we have to drag the DM to this input raster. And for the hillshade 0, we have to write the altitude to 0 and write the name hillshade 0, then click on OK. Then it will take a little time for processing. Then after processing, it will show the final raster image for the hillshade 0. So the process is completed, and you can see the file is created for the hillshade 0. Simply uncheck below. Then after this, we are going to create for the 90-degree hillshade, and for that you have to simply click on this hillshade. Then you have to drag the DM into this input raster, and from here you have to change the value of altitude to 90-degree and write the name hillshade 90. Then click on OK. Then after this, it will process for the 90-degree hillshade. So you can see the process is completed for the 0-degree and the 90-degree. So we are going to add this hillshade 0-degree and the 90-degree. And for adding this, you have to go to the Raster Calculator. Then you have to click on this hillshade 0, then plus hillshade 90-degree. Then you have to click outside, then write hillshade sum. Then doing this, writing the name, then click on OK. Then it will add the hillshade 0 and the hillshade 90-degree raster file. So simply uncheck for 0-degree and 90-degree, and you can see the final raster drawing or raster image for the sum of 0-degree and the 90-degree of the hillshade, and this is the final drawing. So in this way, just we have completed this task for adding the hillshade 0-degree and adding the hillshade 90-degree, and create a new and by creating a new hillshade raster. So in this way, we have completed our fourth number of exercise of Raster Calculator. So after this, we are going to solve, or we are going to calculate the weighted overlay. And for calculating the weighted overlay, the syntax or the command is like this. You have to go to the Arc toolbox, then spatial analyst tool, then overlay, weighted overlay. So go to Arc GIS, simply uncheck this, then you have to go to the overlay from this spatial analyst tool, and I have to search for the overlay. Yeah, it is overlay. So you have to click on the plus icon, and from this plus icon you have to click on this option, weighted overlay. So it is, so simply double click here and click on plus, and from this plus you have to click here. So at first we are going to add for the classified elevation, then click on OK, then plus, then we are going to add the classified slope, then OK, then write the value for the percentage influence for the classified elevation as 50, and write, then after doing this add the value for the classified slope as the 50. So writing the value 50 and 50 for the classified elevation and classified slope, you have to simply click on OK. Then after processing, it will show the final drawing of weighted overlay. This weighted overlay is the 10th number exercise. So after processing, it will show the final raster image or final raster drawing here. So this is the final raster image of weighted overlay. So in this way, we have completed our 10th number of exercise, that is weighted overlay. So in this last number, we are going to convert the land possibility map, that is this map, into the vector, because we are because we are doing the task in the raster. So this is the raster file, and this raster file we are going to convert into the vector file. So for that you have to go to the conversion tool, and the conversion tool, for that the syntax we can see from this PDF. Go to Arc toolbox, then conversion tool. This is Arc toolbox, and from this we can see the conversion tool, and from this conversion tool you have to click here on, that is from the raster. This is raster. So from raster we are going to convert to the vector, and so for the vector we are going to convert to the raster to polygon. So simply you have to double click here on the raster to polygon. Then after this we have to drag this file weighted class into the input raster. Then after this write the name weightage vector, then click on OK. Then after this it will convert this raster file into the vector file. It will take a little time for processing, we can wait. So the process is completed, that is from the raster to the polygon. So you can see this is the vector file, and simply uncheck below file, and right click here and go to open attribute table. Then from this you can see there is 3 number of region, but it is scattered for the object ID. So we are going to merge this grid code, that is the number 3 into the single file, number 2 into the single region, and the number 1 into the single region by using the tool dissolve. And for that go to search and write the dissolve, then search, and from here you have to choose the dissolve data management, and from this you have to drag this weightage vector, and from this dissolve field you have to click here on the grid code, then you have to drop down, and from this statistics field you have to choose the shape area. Then after this you have to choose the type, then the type is sum, then click on OK. Then it will simply dissolve the boundary area into the 3 number of region. And after the process is completed, we can see from the attribute table the final result. So the process is completed, and you can see from this file, simply uncheck below file, right click here and open attribute table, and you can see that the one number of region is created, 2, 3, and it means 3 number of total region is created by merging the object ID of same region. So if you click here, so the corresponding region boundary will be selected, so likewise others. So in this way we have converted and dissolved the raster file to the vector. So in case if you want to convert this vector file to the raster, for that you have to go to the arc toolbox, and from this conversion tool you have to click here to raster, and from this raster you have to click on this polygon to raster. So this process is for converting the vector file to the raster. So in the input features you have to simply drag this and write the name vector dissolve raster, then OK. Then it will simply convert this vector file into the raster. It will take a little time for the processing. Yeah, the process is completed. Simply uncheck above and zoom to layer. Process might be wrong. So for converting you have to simply, let me check. So let's begin again. For converting this vector file into the raster, for that you have to go to the polygon to raster, then it is vector, object ID, then OK. Simply click on this main attribute table. So in this way, just we have converted, or at first you have to go to this properties, change the color, then it will show the appropriate figure. Yeah, this is simply uncheck this and uncheck check this above, check the before file, go to properties. Simply click here, click on apply. So in this way, we have converted the vector file into the raster and the raster file into the vector. So in this tutorial, just we have learned about this number of function of the raster analysis. So the I hope you understood the basic of raster analysis in tutorial, in this tutorial 7 of raster analysis. So in the last tutorial, we are going to learn about the spatial interpolation. So after completing the spatial interpolation, the tutorial for the Arc GIS is completed for the vector and the raster. So thank you, and please subscribe to our channel. Thank you so much.